Okay guys, welcome. We are going to continue on with our proofs, but today we're going to talk about parallel line proofs. So let's go ahead and review those parallel lines and a transversal. So remember, a transversal is a line that intersects two or more lines at different points. So this right here is our transversal because it's intersecting these two parallel lines. Corresponding angles, two angles that lie on the same side of the transversal, okay, and then they're in corresponding positions or the same position. So if we pick this angle and we slide this section down, it's going to line on top of this part. So these two are corresponding angles and they're going to be congruent, okay, they're going to be equal in measure. Alternate interior angles, so they are alternate tells us they're on opposite sides of the transversal. Interior is telling us they're inside the parallel lines. So these two angles would be alternate interior. Okay? Along the same lines, we could also say that these angles are alternate interior. Again, these will also be congruent angles, so their angle measures will be equal. So if this is 25 degrees, this angle is 25 degrees. Alternate exterior, so the alternate is telling us it's on opposite sides of the transversal. Exterior, they are opposite of the parallel, or outside of the parallel lines, so we have this angle and this angle to be alternate exterior. They are also congruent. Okay? Supplementary angles, so those are just going to add up to 180. In our parallel lines and transversals, we could have these angles add up to 180. These angles could add up to 180. There's a few options. A lot of times, supplementary angles will either be linear pairs, like the ones I've highlighted, or they will be consecutive interior or consecutive exterior, okay? Vertical angles, they're going to be across from each other vertically, okay? We also could say this angle and this angle are vertical angles, and they're going to be congruent. Consecutive interior angles, one of the examples I gave up here, so interior, they're going to both be inside the parallel line, or inside the parallel lines. Consecutive exterior are going to be ones that are on the same outside. So they're outside, but they're next to they're consecutive, so they're on the same side, okay? Sometimes they refer to these as same side or consecutive. Those are interchangeable. These are going to be supplementary options, or the angles will be supplementary. So just a quick summary of all of this. So we did this a while back. We did this before we did this whole digital learning, so it was a while ago. Corresponding alternate interior, alternate exterior, and vertical angles are all going to be congruent or equal in measure. And then consecutive interior, consecutive exterior, sometimes they're called same side interior or exterior. Okay, and then the linear pairs, those are all going to add up to 180. Please remember that the two straight lines means parallel, and then the upside down T means perpendicular. So that means they meet at 90 degrees. Or they form a 90-degree angle, I guess is a better. They form 90-degree angles. It's nice because it makes that nice T that looks like a 90-degree. Okay? So we're going to use what we know about angles. And we have these reasons, theorems, postulates, definitions that we can use. The transitive property, so that's saying if A equals B and B equals C, then A equals C, okay? So let's say if I know angle M is equal to angle P, and I know angle P equals angle W, I can take this out and I can prove and know that angle M is going to equal angle W, okay? Because these are equal, so we can use this transitive property. If one thing equals something and that something equals another thing, the two things equal each other, okay? Substitution, if A equals B, then it may be replaced in any equation, okay? So if we know x equals 5 and we have 2x equals 10, okay? We can plug in x for, or we can plug in this 5 for x to solve, okay? We can substitute it in. Definition of supplementary angles, they're going to add up to 180. Definition of congruent angles means they're the same or equal. Okay, and then these are literally just telling us what we know is true about angles, okay? So corresponding angles, so if two lines are cut by, or if two parallel lines are cut by a transversal, corresponding angles are congruent. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. If parallel lines are cut by a transversal, alternate exterior are congruent, and then consecutive interior are going to be supplementary. Okay, so this we already know to be true. These are now just giving a formal name to what we know. Okay. And these are what we're going to use in our proofs. And then we have our converse. Okay, converse is just telling us to flip the statement. Okay, so here, so let's say for the corresponding angles, okay, we knew if two lines are parallel, then the corresponding angles are congruent. This is just switching to say that if we know corresponding angles are congruent, then the lines have to be parallel. Okay, so this is just saying if we know the angles are equal, then the lines are parallel. Okay, so these will be only used when your proof is M is parallel to N, or proving that two lines are parallel. Okay, so we're gonna go ahead, before we even go to the formal proofs, I just want us to run through this, okay? So, if angle 9 is congruent to angle, use the figure to determine which lines are parallel, justify them by using these theorems, okay? We're trying to prove if they are parallel, okay? So that means we're gonna be using these. So angle 9 is congruent to angle 16, okay? So I'm looking at it and I'm like, okay, here's my transversal and my parallel lines. So these are alternate exterior. So that means A and B are parallel because of the converse alternate exterior, okay? Now that we know A and B are parallel, I could say, so now that we know A is parallel to B, then we could say angle 9 is congruent to angle 11 by the corresponding angles theorem. Okay? So because we know the lines are parallel, we can then say other angles are congruent by their original theorem. But when we're trying to prove that lines are parallel, we have to use the converse. Okay? So, angle 5 is congruent to angle 7. Okay, this is gonna be these two. So if angle 5 is congruent to angle 7, that means these would be our parallel lines again, and C is now our transversal. So we would still have A is parallel to B, and this would be by the converse corresponding. Okay. 14 is congruent to 16. Again, that's going to be A is parallel to B by, again, converse corresponding angles. 1 and 16. So now these, that one we have to use a few steps. So this one we're going to talk about in our next proofs. So this is going ahead. And then 5 and 10. So we could say 5 and 10 are congruent, if 5 and 10 are congruent, then C and D are parallel. And it's going to be by converse alternate interior. Okay. So, just kind of looking to be like, okay, we know these angles are congruent, and it's because of this theorem. Okay. So we're gonna go to writing our proofs for these. So we're gonna first looking at that proving angles are equal. We can use parallel lines to prove the relationships between angles. Each proof is meant to be followed like a map. We should use little amounts of angles as possible, only collect facts about congruent angles. We're most likely, this is when we're going to use a lot of that transitive property. Okay, we're going to be making connections out. It's like, okay, this thing equals this, that equals this, so that means these two equal each other. Some tips for parallel line proofs. Okay, I want you to think of the lines as sidewalks. Okay, so we're going to have to stay on the sidewalk. So I'm saying we have to go from here to here. We can't go diagonally, okay? We can't go in the intersection. Or can't go into the, the street intersection. Okay, and then label the diagrams. Okay, those are gonna help us a lot. So, looking at our first example, we're given that N is parallel to N and A is parallel to B. We wanna prove that angle 1 is congruent to angle 15. Okay? So we're gonna start with our givens. N is, okay, yeah, we can go ahead and add that too. Start with givens, cause duh. That's gonna make our proofs the easiest, okay? So N is parallel to M, A is parallel to B. Both of those are given, okay? And then they said 1 is congruent to 5. So, okay, I know 1 is congruent to 5. And they're able to say that because they're corresponding angles. So the corresponding angles theorem tells us that they're congruent, okay? And then they said 5 and 15 are congruent by alternate exterior angles, okay? 5 and 15 are alternate exterior angles. And what they did, so at first they used, they went from 1 to 5. So they were looking at N and M being our parallel lines with A being the transversal. And then they switched and said A and B were parallel and went to the M being the transversal to prove the alternate exterior angles, okay? So they used both sets of parallel lines to make and then used another line to be the transversal, because we know 1 is congruent to 5 and 5 is congruent to 15. We can say angle 1 and angle 15 are congruent by the transitive property. Okay? So just make sure you're following the parallel lines like they're a sidewalk. We cannot go diagonal. We have to go crossing the streets. Okay? Let's go ahead and try this next one. So N is parallel to M and A is parallel to B, and we're trying to prove that angle 2 and angle 14 are congruent. Okay? So we're gonna first start with our givens. So N is parallel to M, and the reason is given. A is parallel to B, and the reason is given. Okay? Now, I am thinking I'm gonna go 2 and then I'm gonna go to 10. I'm gonna walk this way. So I'm looking, here's my parallel line and my transversal. I'm gonna say that angle 2 is congruent to angle 10. So angle 2 is congruent to angle 10. And the reason we can say that is because they're corresponding angles. So corresponding angles theorem. And then we can say 10 and 14 are congruent. Okay, so now if I'm using this parallel line and this parallel line, I can use 10 and 14. I wanted to go this way because then I used the same theorem for both of these. Okay, again, corresponding angles theorem proves that those two are congruent as well. Okay, I have said 2 is congruent to 10, 10 is congruent to 14, so I can then say angle 2 and angle 14 are congruent by the transitive property. Okay. And with that one, so we started with our givens. I worked this way. If you wanted to go like this first example did and maybe go to 5 or go to 8 and then go to 14, you could do that. If you wanted to go, that would have been the best one. Or you could have done 6 to 14 as well. Any of those would work. So it's kind of cool because there's a few different routes you can take on these. And number 2, we're given N is parallel to M and A is parallel to B, and we're trying to prove that angle 9 is congruent to angle 7. So as always, start with your givens. And you'll see in some proofs they combine these. So they would say N is parallel to M and A is parallel to B because they're given. Either one works. We can either go this way or we can go that way. I'll probably go and make a backwards L. So I'm gonna say 9 and 13. So I'm gonna go this way. So I'm gonna use that they're corresponding. And so I know 9 and 13 are congruent. I can say angle 13 is congruent to angle 7 because they are alternate interior angles. And by the alternate interior angles theorem, we know they're true. Okay, mathematicians, I say they're always lazy and don't want to use a lot of words. This is where they use a lot of words, okay? Because we're trying to make this as easy as possible for anyone to read. Right? They can follow it, they know exactly what we're doing, there's no way they can get it mixed up. And then our last reason, so we now can say angle 9 is congruent to angle 7 by the transitive property. Okay? Maybe something else we can think about with our tips. Think of proofs as writing a recipe. Okay, that's gonna help us just keep track of all of our orders, okay? So this first part was proving that angles are equal. We will use the transitive property as our final reason about 95% of the time with these, okay? The next type of parallel lines proofs we'll have is proving that angles are supplementary, okay? So we can use parallel lines to prove the relationships between angles. Each proof is meant to be followed like a map. We should use as little amounts of angles as possible. We must write down one pair of congruent angles and one pair of supplementary angles when writing these proofs, okay? We're gonna be using all of those different angles, and then we're most likely gonna end with our substitution property, okay? So given N is parallel to M and A is parallel to B, we're trying to prove that angle 1 plus angle 6 equals 180, okay? So we know these are parallel and that's given. They said 1 and 5 are congruent because they're corresponding angles. Perfect. We know that's true because we know these lines are parallel and they're corresponding. We know angle 5 and angle 6 are going to be supplementary, okay? Some people would also write this reason as a linear pair, okay? They're going to make a straight line, so we know they're linear pairs. Then, if we know 1 and 5 are equal, I can plug this in for 5, which is what we did in this last step, and that's why we can say it's true by the substitution property, okay? looking at this first example for us to fill in, we're given N is parallel to M and A is parallel to B, and we want to prove that the measure of angle 10 and the measure of angle 13, so 10 and 13 equals 180. Okay, so let's start with our givens. And like I said in the last page, we can combine these if we want to. If you want to write them as two separate steps, you can as well. Either one is fine. So I can say angle 9 plus angle 10 equals 180 degrees. And the reason for that is because they are a linear pair. I know that 9 is equal to 13 because they're corresponding angles. So if I know 9 and 13 are equal to each other, I can plug in or substitute 13 for 9 by the substitution property. And I have proven that angle 13 and angle 10 are supplementary or add up to 180. Okay. Example 2 for us. So we're given N is parallel to M and A is parallel to B. We're trying to prove that the measure of angle 5 plus the measure of angle 2 equals 180. Okay, so we go ahead and start with our givens. We can say angle 2 plus angle 3 is going to equal 180. And the reason for that is because they are a linear pair. We can then say angle 3 is congruent to angle 5. And the reason for that is because they are alternate interior angles. And then our last reason, we're gonna say angle 2 plus angle 5 equals 180 by the beautiful substitution property. Okay. So again with these, the biggest thing I see is that we mix up and put transitive property here, okay? When you're proving angles are supplementary, you're using the substitution property, okay? Sorry, I don't know if you could see that as I was writing that. When you're proving angles are supplementary, we're gonna use the substitution property, okay? When we're proving angles are equal, we're gonna use the transitive property. Okay. The very last type of proof we have are proving that the lines are parallel. Okay. When we know that, we're going to always use a converse theorem. Okay, so we can use angle property and their converse to prove lines are parallel. They must be followed like a map still, okay, and we can use little amounts of angles as possible. So we're gonna be given that angles are congruent and we have to prove that the line is parallel, okay, or one of the lines. So we're given 8 is congruent to 10, okay, and they're not gonna be next to each other, okay, so they're on two separate lines, so we're gonna be able to say, so 8 is congruent to 10, and then we're also given that M is parallel to, I'm sorry, that should be an N. Yeah, these should all be N's. Okay, so M is parallel to N, okay. I like to highlight the ones that I know are parallel because that helps me know which way I can travel, okay? So because we know these are parallel, they went to 8 and 4 being congruent, okay? So they said those are congruent because they're corresponding angles. They are corresponding angles with M and N, okay? And then we know 4 and 10 are congruent. It is actually not by the alternate exterior angles theorem. That's going to be by the transitive property. Okay, so by the transitive property, because 8 is congruent to 10 and 8 is congruent to 4, we can say 10 and 4 are equal to each other. Okay, so because we know 10 and 4 are equal to each other, we can then say, okay, that these would be alternate exterior angles for A and B if they were parallel. So by the converse of the alternate exterior angles theorem, A is parallel to B. Okay. In this next example, so we're given 5 and 14 are congruent, and then M is parallel to N. Okay. And we're going to try to prove that A is parallel to B. So we can say, oh wait, I said 15, I read that wrong, angle 15 and angle 4. There we go. Okay, so angle 15 and angle 4 are congruent. Ignore those. Okay, so let's start with our givens and our proof. So angle 15 is congruent to angle 4, and then M is parallel to N, and the reason is given and given. Okay, and then we have to look. So we have to go this way because these are our parallel lines and transversal. Right? So I could say 15 and 9 are congruent. That's not gonna work. This is a typo. Let's say it wants us to prove let's see, we could do angle 15 and 1. I have to change that. I'm sorry, guys, that will be corrected on yours. So angle 15 and angle 1 are congruent, okay? 15 and 4 are not congruent. So then we can say angle 15 is congruent to angle 9. And that is because they are alternate exterior angles. And by the alternate exterior angles theorem, they're congruent. Okay? And then for number 4, I can say angle 1 and angle 9 are congruent by the transitive property. Okay, because we have 15 and 1 and then 15 and 9. I can take out that 15 and those will equal each other. And then since we know 1 and 9 are congruent, we can say A is parallel to B by the converse corresponding angles theorem. Okay. With each of these, y'all, your last statement, if your last prove statement is something is parallel, your last reason will be a converse. Okay, let's look at this last one. We're gonna say 1 and 13 are congruent. Okay, and then we know M is parallel to N. So we can go ahead and write our statement. So angle 1 is congruent to angle 13, and M is parallel to N. We are trying to prove that A is parallel to B. Okay, so our very last statement is going to be A is parallel to B. Because that's our last statement, I know it's going to be the converse of something. So I'm going to go ahead and fill that much in because I know that much. So I'm going from 1 to 13. I'm going to go, I can say 1 and 5 are congruent, or 1 and 7. Let's go ahead and change it up. I'm going to say 1 and 7 are congruent just to get some different theorems in here. Okay, so angle 1 and angle 7 are congruent, and the reason for that is because they're alternate exterior angles. Okay, so the alternate exterior angles theorem. And And then I can say angle 7 is congruent to angle 13, okay, by the transitive property. Okay. Because I know 7 and 13 are congruent by the transitive property, they play the role of alternate interior angles. So that means A is parallel to B by the converse alternate interior angles theorem. Okay. That is what I have for the notes. I can do a quick summary for y'all. So, let's see. So our summary, always follow lines like they're the sidewalk. I'm saying don't go diagonal. Okay? You have to follow the roads, okay? We can't go from here to here. Okay? We have to go here to there to there. Okay? We have to follow them like they're the sidewalks for us to walk on. Mark your diagrams. Transitive property is saying angles are equal. So for angles are congruent angles, okay, substitution property is going to be with the sum of angles. If you are proving A is parallel to B, your reason will always be a converse. Okay. If it helps, maybe the parallel lines are telling you that it's the shoelaces on a string. I don't know. We can also say if the statement is A is parallel to B, or a line is parallel to a line, your reason is either given or converse. I think that's pretty much all I had for you guys. Think of it like it's a recipe. Label the diagrams, start with your givens. And then just think logically. You guys are all smart at these, okay? So the practice today, you have two options. Option 1, the problems and the notes. So the practice problems at the end of the notes, okay? So these, you are gonna fill in 6 proofs about parallel lines, okay? You're given the diagrams. You will upload a picture of your work to Google Classroom. Okay, so option 1, you can do the practice problems on this worksheet. They're attached to the notes at the end of the document that's attached for the assignment. Option 2, quizzes. Either one's fine with me. Y'all know how the quizzes work. If you want to do both for practice, that's totally fine. I'm happy to do some bonus points with that. Just make sure you guys are practicing this to get comfortable with it. I know this is weird to learn not face-to-face. This is challenging. Please don't be discouraged, okay? I love you guys. Miss you. Let me know if you have any questions.